We are going to hear from Dr. Ali Memari, who is among many, many other things, the director of the Penn State Housing Research Center. And he directs an extreme amount of research on lots of different things, including hemp. And so for those of you who are curious about the performance of it, this is going to be really good detail for you. So we're going to hear from Dr. Memari. Then we're going to hear from Michael and Anna. And I think we'll probably then break for lunch and then come back for Q&A with these speakers so that you guys can ask them your questions. So Dr. Memari, there you are. And you just click the green arrow.
Thank you. This one more. Thank you. It's a pleasure to be here and speak to you. Do you hear me well? Okay. Let me first put this on the next slide. So I want to first introduce myself and what I do and my connection to the team. My colleagues here, they do Hempcrete for a living. I'm a professor, so that means I have to kind of find research area. I was just talking to other former graduates. We have to identify new research areas so that they can do their thesis, the research. So that's part of my job as a professor. But also I'm a director of Pennsylvania Housing Research Center. In that space, what we do is mostly outreach. We have a staff, 5 or 6 staff that they train and teach builders. Any new development in the code, any new materials, any new methods, they try to hold sessions in person or through webinar and Zoom. They try to educate Pennsylvanian builders. So that's part of their job. My job as the professor and Hankin chair is in residential construction is really identify new areas for housing, for residential building construction. Not so much for the housing as we understand it, but more at the building construction and new materials. So for instance, I look at CLT, cross-laminated timber. I love this material. You know, we're trying to develop a house design, whereas it's conventionally used for multi-story. We like to develop it for house design. We're looking at air barrier, vapor barrier for passive house design. Now, we just talked about what if the air barrier and the tape does not hold on well after a few years? Now, imagine you're in California building a passive house. With these earthquakes, you know, the tape's going to come off, then all of your design is gone. So we're trying to investigate what is the effectiveness of tape, what is the effectiveness of a barrier. We're looking at building homes in the coastal region where you have hurricanes. So how do we design homes that would resist hurricane, that resist flood? Some of them are elevated. So we look at the wind speed, we look at the structural design. We look at tornadoes. How do you build homes that will not get destroyed in tornado? Now, you probably have seen some pictures from concrete homes, right? Concrete homes survive tornadoes. But CO2 and concrete, you say, no, wait a minute, we don't want to use concrete in those areas. So what about CLT? We're investigating using CLT to build homes in tornado regions. And then, of course, we have to venture in the new areas, like how about we combine plastic with concrete? You know, just reduce the carbon footprint. I'm developing some concrete that actually does not have any cement and does not use any water. It's a concrete that gives you 3,000 PSI, but I'm using plastic. So we're using innovative approaches in coming up new materials for home building. We're looking at, for instance, also method of construction. Like, what about 3D printing? Can you 3D printing homes? We are doing that. We've done a lot of research up front. We actually have a project that we're going to build a home in Alaska out of 3D printing of concrete. But again, once the companies are out there are doing 3D printing, then where is the research? Well, the research, you have to kind of identify new elements in that, even 3D printing. For instance, I'm using plastic in the mixture so that the concrete is actually lighter, is more insulated. So we're trying to come up with, let's say, reinforcement for 3D printing concrete, right? Because you can print it, but what about reinforcement if you want to have resistant to loads? So we have to identify new areas of research. And so that brings me to this discussion that Hempcrete, in my search of finding new materials for home building that are more sustainable, about 2017, I discovered Hempcrete. I said, what? This is interesting. Never heard of that. And so we got involved with a couple of other colleagues. And of course, they said, you know what, this is illegal material. So why don't you invest your time? I said, well, that's fine. Canada is using it. Europe is using it. Let's see what's going on. Year into our research, then it became legal. I said, wow, this is good because now we're ahead. So my role was to identify what can we do with hempcrete? How do we build homes? Can it be used besides just insulation? So we start looking at the strength. We start looking at the maybe different forms. As of course, my colleagues here already mentioned, block is one way, panelized is one way. But my role is try to help them, the industry, maybe solve some of the testing problems, testing issues, because we have laboratories. I mean, universities have laboratories. And then, of course, we have the best and the brightest graduate students. I mean, this is my pleasure to work with 9 PhD students and 5 master's students. Of course, I don't sleep, but it's still I enjoy it because, I mean, it's just the best moment is when I sit down with each one of my grad students, we talk about the research. And of course, you know, the result is that they go out there, they become one of you guys. You go and shine, and that's our job. So with that as the background, what are we going to discuss today? Now, of course, I should first apologize for some of the repetitions because my colleagues already talked about the good stuff. So I'm going to skip through some of this quickly because the presentation is for a crowd that my colleagues were not there. So my stuff would be new, but they already talked about it. So anyways, some introducing the hempcrete, what is the makeup, methods of applying hempcrete, they already talked about it. I mean, I don't really have much to talk about. Attributes, and then some of the testing for Pennsylvania Hemp House, and then hempcrete research to increase compressive strength, and then just finding new areas. I'm trying to see, can we 3D print hempcrete? So we've done some early study on that, and maybe come up with, combine it with other materials that probably my architect colleagues here would like to see. So hemp, we've already talked about it, and I'm going to just skip through this because there is no need to repeat. You already have a lot of information today about growing hemp and what hemp is. The mixture, obviously, you have hemp part, maybe some fibers, lime, and water. That's your basic ingredients. Once you mix these, and then you make your concrete or hempcrete or hemp lime, whatever they want to call it, it doesn't have much strength. It's very, very weak. You can basically punch through it, and your fist will go through it. But it has its own space, right? It's a good insulation. I'm trying to find what can we make it a bit more stronger. What do we add? So that's the research. And so I have a student who's trying to figure out what ingredients, what additives can you add to make it stronger, get more PSI out of that. So again, these are just the basic ingredients. And again, Cam has already shown you the French product. And this is again Cam's operation. Again, I apologize, it's repetitive, but you've already seen these. And so again, the 3 basic ways of building homes, constructing with hempcrete, casting in place. You got to have a little form, as Cam mentioned, and then you kind of tapping, and then of course you move the forms up. You can have blocks, and of course the spray. So this is the attributes of how you actually build, just like regular block, but of course the masons in that case, they're not going to get backache. This stuff is pretty light. We have one sample over there. Make sure you lift it, and you see how light it is. Spraying hempcrete, again, that's Cam's basically favorite approach of putting the wall up there like that. And of course, precasting blocks. And then the next level is that I think I also mentioned, Cam mentioned that in his warehouse, he has panels. So panelizing probably would be a better idea. One of the advantages of panelizing, again, the experience that we have with the hemp house is that it took so long to dry. And so you can't put the coat, the finished coat. That was the deterrent. The other thing is that it's a mess on the ground floor on the ground. And you got to spend a lot of time to clean up. But this is clean. This is nice. You can control that. In fact, you can go add if you want any. This of course doesn't need any air barrier, but you can finish that as well. You can put the siding on the other side. You can finish the interior. Just send a complete package to the job site, and so this way you save a lot of the labor. And then composite, maybe add maybe clay, straw, like a adobe, maybe combined with Hempcrete. And we're investigating that for the 3D printing. I'll show you in some slides toward the end. So there are ideas that, especially architects, you guys are designers, you can come up with ideas. And then if you think that, well, this has to be tested before you actually build something, that's where we come in. That's where we tacked in. That's how I'm working with these guys. And then what about reinforcement? Can we reinforce, these walls? Different ideas, different mesh can be used. So I had another slide. I think I'm missing that slide. But anyways, these are some of the, these graphics. They show you, let's say you build a concrete wall, one concrete wall, right? 1 cubic meter of one concrete wall emits 1,500 CO2, kilogram of CO2. You get 5 of these walls made of hempcrete. They actually absorb 1,500 kilogram of CO2. So that's how we actually can compare them, and as far as the sustainability is concerned. But then there are a lot of other advantages with hempcrete, and there are numbers that one can assign, but I didn't want to kind of get into a lot of numbers with these. But for all of these, there are some tests that have been done, some studies have been done. We're publishing some papers that we're assigning some values to sustainability, low environmental impact, carbon sequestration, high tensile strength, lightweight, thermal insulation, fire resistance. And Cam mentioned a fire resistant. I think I have one picture of that he was talking about. So this basically shows that you can hold a flame on this material and it's not going to burn because of the lime. So there's a lot of good properties that this material has, but it needs to be developed further. Architects especially need to start using that, like a showcase, maybe demo houses. I think that's the key. If you have demo houses in different parts and bring clients, maybe you talk about Toll Brothers. If you build one demo house and you bring Toll Brothers, they say, well, we like that idea. So then the makeup can be different. Again, that's part of the architect's design, or however you want to design the detail, that's fine. You have at this stage, you're just saying that it's like a rigid insulation on the interior side, between the siding and your studs, but you can have it between studs as we saw in the other pictures. And just a few slides on the Pennsylvania Hemp House. Again, I had the pleasure of working with this team here. It's a magnificent team, very unique, very talented. They did the design, they did the construction. Our job was to kind of study, measure. And there was some interest about the question about the R factor, right? What is the R value for this? If you have an R value for, let's say, an inch of hempcrete, when you actually build that, you can't say, well, I have 10 inches, so that my R is 10 times what I have for 1 inch, because you have siding, you have interior, exterior. So the best way would be to actually measure, once you're finished with this, instrument this and measure the actual R value. And this is what we did in our study. So these are just different details that our architect colleagues have developed for this. And here's the staircase before, plaster, finish, and after. And this is just putting the coat, the finish coat on this. And this is the part that I'm talking about, that we can take a wall that you built, we can instrument it, we can put sensors on the inside, sensors on the outside, and we measure the heat transfer. And through mathematical model shown on upper right corner, we can develop actual R value. So for this wall of the house, we came up with R17. Now, if you start doing calculations, you can get something close to that. In other words, we have models that we can calculate. You can calculate per inch, and then you have the air gap, you have the siding, you have the coat finish. But at the end of the day, if somebody, can you prove that? We say, okay, this is the proof. We can set up instruments and we basically get the reading from the instruments. So for this wall, which consists of 3/4 of an inch of rich plaster that is like a double lime on the interior, 10 inch of Hempcrete, 1/2 inch of airspace, and 1/2 inch of siding. That gives us an R value of 17. Now, this is what it was created. Now, if you want to have a passive house, say, well, no, I need much more than that, then Cam has to thicken that wall, maybe go 12 inches of Hempcrete, then we reach whatever you need. And if you, as mentioned, you want to have it for the roof, that's fine. Above ceiling, instead of spray, you can have this Hempcrete. So there are possibilities. And then the other part of our study was energy efficiency. We use BOP. Most of you are familiar with this program. So we did a study and we determined that 75% reduction in total energy usage between pre-retrofit and post-retrofit. So that means the initial house and then after it was retrofitted. That's a lot of energy savings. And the other thing, again, Cam has already talked about the properties, the humidity, because this material can actually absorb humidity and it can release it. So it's nice because the relative humidity was always less than 60%. You don't want the house to be too humid. It just absorbs it. And so when you go to the house, I don't know if maybe Lori can arrange for some visitors to go in. First of all, you go inside, it smells good. Number one. Number two, it feels good. And it's very quiet as well. So there are a lot of things that you can feel about a house once you enter it. So with that, I want to now switch to the kind of research side, because that's where I have to work with grad students. If they want to do thesis, it's not what we just talked about, because that's Drew and Cam doing the job. But what about research? Well, research is that, okay, you want to increase the compressive strength. We have to just do trial and error, because there's no formula. We have to just try different things. We have to try different additives and just test and test and test until we find something that actually improves. So, and that's what defines research for a graduate student. Okay, let them loose in the lab. I tell them, okay, you've got a lot of variables, work with them, come back and let's meet and see what we get. So we just do trial and error, different materials, different percentages. We test them, see what strength we get. But unfortunately, currently we don't have much, like 140 psi compressive strength of 140 to 160. That's just nothing. So that's why we're not relying this on load bearing. But again, Drew has a great interest in making this his blocks stronger, and so we're working together to identify, find maybe secret recipe, some additives. We're working on that, and I have actually a graduate student working on this specific question of what additives can we add to make this much stronger. So I don't have any results to share with you yet, but we're working on that. Tensile strength of this, again, we go in the lab and it's very, very small, 32 psi. It's extremely small tensile strength, but that's what it is for now. And then super plasticizers, other additives. Again, these are the favorite kind of task for a grad student, to just go in the lab, change the percentages. Let's see because there is nothing out there that we can say, oh, well, that one actually works. We have to come up with that, and that defines the research. Again, do testing further, and just identify, what happens if you increase an ingredient or decrease an ingredient. Come up with some results that will show us the next step. So step by step, we kind of find the direction that improves the results. At the end, increasing the hemp content is going to decrease the compressive strength. but you increase the binder, it's going to increase the compressive strength. So there are different also ways that, again, as I said, I don't have results to share because it's ongoing research at this time, but we have come up with some ingredients that we can increase definitely the compressive strength. Now, moving further away from just basic research of strength, we want to see what are the other ideas that we can use, like clay, using clay and hemp. What about Adobe? We use straw and hemp, straw and clay, right? What about, instead of straw, what about if you use hemp and clay, and you come up with a new kind of Adobe? So we've been testing that, and also exploring the possibility of 3D printing of the clay mixture. We tried to 3D print Hempcrete. It was not successful. It was difficult. It would just get stuck in the hose, and in the pump had difficulty to give us good results. So, but nonetheless, we're kind of exploring. We're testing. I have a PhD student. Actually, she's doing this work. Get basic information about the properties, the materials. But then there are architects who love to explore natural, sustainable material like this here. Wasp is an Italian company that is promoting building with clay and straw and rice husk for insulation. And so we got some ideas from this company, and then my student actually is trying to kind of work something toward that goal. And we're thinking that, here's the thing about the 3D printing. One of the advantages is that you don't have to have straight walls. You can have curves. And so as you see these curved shapes, this particular student is, she's from Africa, and she has this heritage of this sort of homes that's red. And so we got these ideas that, well, if this is the traditional home, we can actually 3D print these things. And so because we saw that Wasp is doing that, so we could do that as well. And so that was part of the motivation. This is our laboratory for 3D printing. So you have the robotic arm, you have the mixer, you have the pump on the right side, and we developed toolpath design, that controls the movement of the robot. And so this is 3D printed Hempcrete, which again was not very successful. So initially we were excited because we were trying to say, okay, well, Wasp is printing clay, we're going to print 3D Hempcrete, but it just didn't work out. And so we said, okay, we go to plan B. Plan B is we're going to 3D print the clay mixed with hemp, but then we're going to fill all of those cells with Hempcrete. Now that becomes a good idea, because now you've got the insulation built into it, and then you've got the ability to actually 3D print. So this was the final result of that approach. Here you see 3D printed mixture of clay and hemp, and then of course the cells will be filled with Hempcrete. And so just to summarize this line of research, again, we try to investigate what we can do with Hempcrete as far as strengthening increasing its strength, maybe using it in a different environment. And this is one of the approaches that we have seen. So with that, we see that there's a future. We believe that there is a future for Hempcrete. It just has to find its own niche, especially architects. Once they become familiar with this material and what you can do with it, then sky is the limit for you guys. You guys just take off with it. And we're looking for that moment, that time where you guys come and say, well, we're going to build and design these homes, and we need a little bit of research. And I'll be happy to help you at that point. So a lot of my students have been helping me, especially in this research. Idem Dinega, Masa Hashimi, and Bahar Taibani. I'm going to just acknowledge their contribution. And with that, I'll be happy to answer any questions you may have.